Scientific notation. So scientific notation is a way to write numbers using powers of 10. Let's write that down, and then I'll show you what I mean. So a way to write numbers using powers of 10. So it's really going to be a way to write really large or really small numbers. So it's going to look like this. The form is, so every scientific notation number is going to look like this. A times 10 to some power. Now the A has a specific rule. So 1 has to be less than or equal to A, which has to be less than 10. So could A be 1? Yes. Could A be 1.4? Yes. Could A be 10? No. Could A be 9.9999999? Yes. So this first number has to be between 1 and 10. The exponent has to be an integer. What's an integer? It's a whole number or a negative number, no decimal points. Okay, so let's just see what these look like. So I'm going to give you a number, and you tell me if it's in scientific notation or not. So if I gave you 42.5 times 10 to the third, is that in scientific notation? No, because 42.5 is bigger than 10, so this is a no. There's your reason. Let's write that. 42.5 is greater than 10. That's why. All right, try another one. 1.4 times 10 to the negative sixth. Is that in scientific notation? Yes. This is between 1 and 10. Negative 6 is an integer. You're good. How about 9.987 times 10 to the 0.5? This is a no. This part is okay, but the decimal as an exponent, so 0.5 is not an integer. That's the reasoning there. Okay, so what we're going to learn today is how to change a really large number into scientific notation and back again. So how to go from scientific notation to a really large or small number. Okay, so first for, how do I want to do this? I guess I'll do Roman numeral 1. So for large numbers. Okay, so here's your example. Let's say it was 4,200,000. So to write that in scientific notation, you're going to take the decimal point, here's the decimal, right? You're going to move it over until you get a number between 1 and 10. So it would be right here, right? 4.2 is between 1 and 10. And then it's times 10, and then you count how many times you moved the decimal point. So don't count where you start, count the moves. 1, 2, 3, 4, 5, 6. So that would be 4.2 times 10 to the sixth. All right, let's try another one. What if it was, I don't know, 52 billion. All right, so where's the decimal? Here. You're going to move it over until 5.2. How many times did we move it? 3, 6, 9, 10. Okay, that would be that one. Let's try another one. How about 44,000 for 44,400,000. Let's try that one. So let's move it, move it, move it, move it. 44.4, no, 4.44. So yeah, you write any non-zero number, right? Keep going. Times 10 to the, we moved it 3, 6, 7 times. Okay? So we can write rules here. So we're going to move the decimal until you have a number between 1 and 10, right? So move the decimal until you have a number between 1 and 10. Then you're going to write the number that you have, drop the zeros. So write the number, drop the zeros. And then the exponent on the 10 is how many times you moved the decimal. Right, that's really the general rules for large or small. All right, so actually let's try some really small numbers, change them into scientific notation. So here we go, this will be number 2. Same rules for small numbers. So what am I up to here? Example 4. Let's see, something like 0.0000351. Okay, that's a small number. So let's move the decimal until we get a number between 1 and 10. So I'm moving. 0.351, no. 3.51, yes. Times 10 to the, now how many times did I move it? 1, 2, 3, 4, 5. This time, guys, it's going to be a negative exponent. So I'm going to put here, it's the same rules, but the exponent is negative. Okay? Because you're really moving it in a different direction, that's why. So if it was just something like 0.0067, right? You're going to move the decimal point. Boom, boom, boom. 6.7. I moved it 1, 2, 3, so that will be times 10 to the negative 3. All right, one more. How about 0.00078? See if you can get that one. That would be 7.8 times 10 to the negative 4. Okay, good. So that is going from what they call standard notation into scientific. Now we have to be able to go the other way, so let's call this right in standard notation. So standard is just what we're used to, just the normal number here. Okay, so it's pretty simple. If it's a positive exponent, then you're going to move the decimal right that many times, which to me makes sense. Where's the positive numbers on the number line? To the right. If it's a negative exponent, you're going to move the decimal left. So we're just counting, okay? So let's try one. Example 7. So if I gave you 3.8 times 10 to the 4th. So you write down the 3.8. Don't put the point, though. Put your pencil where the point was, and now move the decimal. That's a positive 4, so I'm going to go 4 to the right. 1, 2, 3, 4. Every loop, you're going to fill in a 0. So that's 38,000. Okay? If it was 3.45, times 10 to the negative fifth. So now you see a negative, you're going to be moving the decimal left, so give yourself some space here. Write the 345. Put your pencil where the decimal was, and you're going to move 5 to the left. 1, 2, 3, 4, 5. Put your decimal point, and there you go. All right, try a couple more. How about 1.72 times 10 to the negative 2 and 9.875 times 10 to the positive 2. All right, well, this one would be boom, boom, 0.0172. And this one here, I'm moving the decimal twice to the right. Boom, boom. Oh, 987.5. All right. And there you go. There is scientific notation. Good job, guys.